All right, so now that we've done equations for finding average rate of change, we're going to look at tables and graphs, okay? So this is, I believe, a little easier because there's less possibility of making mistakes with like ordered operations or plugging things in the wrong way. Basically, it's the same idea, but we're just finding the point from this. So let me just go into the first problem, it'll make more sense. Okay, so we have x is equal to -1. Okay, and normally we plug it all in, but let's just look at this table. At x is equal to -1, what's my y value? Oh, -3. So all that work that we had to do for the last lesson, we don't, right? We can just go straight to the first point, which is -1, -3. So I probably wouldn't even write all of this. I would just write, okay, -1, -3 is one point I'm looking at. Then the other x value I'm looking at is 2. Looking at this table, when x is equal to 2, my y value, or a of x value, is 6. Okay, so guess what my 2 points are? These two. So then from there, we're just going to find our slope. So 6 minus -3, and then 2 minus -1. Okay, so be careful, because remember these two negatives make a positive. Okay, so we'll have 9/3, which is equal to 3. So our slope for this table, or average rate of change, sorry, from -1 to 2 for this table is 3. Okay, and so we're going to do the same thing. So if you feel good and you want to pause the video and start and try these next two, you may. If not, I'm gonna run through some more. All right, so let's just look at this next table. Okay, we're going to look at our first x value. It's -1. So my first point is at -1, 1. And then our other point is at 2. My y value is 7. So my other point is 2, 7. There you go. So we have x sub 1, y sub 1, x sub 2, y sub 2. And we're just plugging in 7 minus 1 all over 2 minus -1. Okay, and so we'll get 6 is equal to, remember to add if you have two negatives, so this is 3. So my average rate of change here is 2. One other thing, I meant to review this before we started this lesson, and if you're wondering where this is coming from, it's coming from our slope formula, which is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Okay, so that's what I did for both of these. I should have reviewed that before. But just going back, this is what we did all last lesson, was use this formula. Okay? So we're going to the last one. At x is equal, again, x is equal to -1. So my first point is -1, -2. And then at x is equal to -2, so at 2, my y value is 5 for this table. So I'm going to label it. So we have 5 minus -2 all over 2 minus -1. So this is, remember, we got to add. So 7/3, okay, 7/3 is a fraction. So I'm just going to do 7 divided by 3, my calculator, and I get around 2.33333. Okay, so I'm just going to round to 2.33. Okay, then, as usual, okay, when I'm looking at all these, it'll ask me which function has the greatest average rate of change over the interval -2 or -1, 2. So again, we're looking at -1, 2. So that's what the average rate of change that we're looking at is these answers that we just found. So we know the least is 2, the second greatest is 2.33, and then the greatest is 3. So my a of x function. Okay, so they usually differentiate functions based on by changing this first letter. So normally we deal with f of x, but if we're dealing usually with 3 different ones, they used a of x, b of x, and c of x. So that's just where this is coming from, and that way it best labels which function you're talking about. Okay, if yours is colored like mine, I would take your answer like the red one, or A, you know, I would take that too, as long as you're giving me the idea that this is the biggest one, okay? Has the greatest average rate of change. Okay. So let's read this next one. My camera was working great. Okay. There we go, we can see now. All right, so this is kind of something we haven't seen before. Basically what they did is, let's look back up at this one. In this first question, they had 3 different tables, okay, but they separated them all. In this next, number 5 question, that's why my camera's moving. Okay, in number 5, what they did is they took 2 tables and they put them in the same table, which still works, right? Okay, so it says, consider the table below that shows the partial set of values for 2 continuous functions. So we're looking at f of x and g of x. Okay, these are our 2 functions. Based on the interval x provided in the table, which function always has the larger average rate of change? Okay, so we're going to look at this, and we're going to see, okay, what would be the average rate of change between -1 and 0, okay, for both of these functions. Then we think of it, okay, from 0 to 1, what is that average rate of change? From 1 to 2, what's that average rate of change? Okay, so we're looking for which one is larger for always, okay? So let's look at this first one. We'll just find the interval between -1 and 0 first. So -1, -2 would be my first point, and 0, 0. So I'm just taking, this is f of x, okay, this is g of x. I'm always run into this little, what do you call it, like a hole in my table. My husband made me this table, and it's made out of wood, and it's really nice, but there's also little grooves in it that get in my way. All right, so then this next one would be the points we're looking at are -1, -4, and 0, 0. Okay, so we're just going to find our average rate of change between these two. So this would be, again, we'd label these. So 0 minus -2 all over 0 minus -1. So this is 2 over 1, or 2. And then over here, this is 0 minus -4 all over 0 minus -1. 4 over 1, or 4. Okay, so right now it looks like g of x is always going to be greater. So just to make sure we are correct in saying this, I mean, it's either always or nothing. So I would go ahead and probably answer this question and say g of x, especially if you're low on time on the test. Say g of x has a larger rate of change. But let's just keep going. So this time we'll find it from 0, 0, 0, comma, 1, 3. So we're going to find our intervals from 0 to 1 for both of these. So 0, 0 again, and then 1, 8. Okay? And notice I'm just getting these from the table. Okay? With f of x, when f of x is equal to, x is equal to 0 for f of x, and when x is 0 to g of x, and then when x is equal to 1 for f of x, and then when x is equal to 1 for g of x, and I'm just putting them in coordinate points, just like we've been doing. Okay, but same thing, I'll do 3 minus 0 all over 1 minus 0. This is 3 over 1, or 3. This is 8 minus 0, and then 1 minus 0. 8 over 1, okay, this is 8. Okay, so from here, I could probably just say, okay, g of x is the greater one for both of these. It's probably going to be greater for this last one as well. So I would go ahead and just say g of x based on those intervals in the table. And we could kind of tell by looking at the table too, like, okay, we know this is going up by 2 here, then going up by 3, then going up by 7. So this is a lot less of a change than this one is. Right, we're going up by 4 here, then 8, and then whatever 8 minus 24, or 24 minus 8 is, 16. So this one's clearly going up quicker than this side. So you can honestly do this one real quick by looking at the table as well, but if not, this is always a safe route to take. Okay, let's go to graphs. All right, so for graphs, it said find the average rate of change from 1 to 3 for each of the functions graph below. So that's supposed to say. All right, so I'm going to just look at where x is equal to 1. Okay, and so when x is equal to 1, I'm going to take my pen, I'm going to take it down to this point, and I'm going to take it over to my y value. So when x is 1, my y value is -3. So 1, -3 is my first point I'm looking at. And then if I'm my second point, it's always going to be, my x value is going to be 3, whichever they're giving me, whatever number they're giving me. And then from here, I'm just going to draw a line from that x value. I would just draw a vertical line with both of these until you hit the graph. Then wherever you hit the graph, you're going to just draw a line over. So I would draw a vertical line up. Okay, it won't hit it down here, but it does hit it up here. And then I'm going to take a line over to 3, okay? So 3, 3, and 1, -3, okay? So then I'll just find my slope. So I'm going to label them like I have been doing. 3 minus -3 all over 3 minus 1. This is 6 over 2, which is equal to 3, okay? So that's my average rate of change from, and this is again what I'm saying with a snapshot. We're looking at the snapshot of these two vertical lines that I drew. So on this portion of the graph, what's the average rate of change on this portion? Okay, what's my slope on this portion? Okay, like if I took the average rate of change from -3 to -1, this snapshot would be a lot lower of a slope. See how so much lower that is? So that's what we're doing when we're finding average rate of change. It's clearly a lot steeper over here than it is over here. So that's why it'll be different if you're looking at an exponential function. It won't be the same. Unlike linear functions, they'll be the same every single time. Okay, so let's look at this quadratic. We'll look at, again, where x equal to 1, we'll draw a straight line. Oh, I meant to say my average rate of change here is 3. So then we'll go over here. X is equal to 1. Okay, it hits the graph here at -4. So 1, -4 is my first point. And then over here, we're going to find x is equal to 3. Okay, I'm going to draw my vertical line. So again, we're looking at this snapshot right here between those two vertical lines. So from 3, we'll go up. We'll go over. Okay, this y value is at 4. So 3, 4. And so then we'll label them. 4 minus -4 all over 3 minus 1. This becomes a plus. So 8 divided by 2 is equal to 4. So right now, the quadratic is winning, okay, as far as how steep it is. All right, but let's go to this last one for the linear function. Okay, linear function, we're going to look at 1. We're going to, again, draw a line down till we hit the graph. So this would be at 1, -2. And then we're going to look at 3. We're getting that from over here. 3, we're drawing a vertical line. And notice it's already hitting 3. So I'm going to look over here at my y value at 3, and it's 0. Okay, so that one was a little harder to see. But just know if it's on this line, it's my y value is 0 there. Okay? All right, and then x1, y1, 0 minus -2 all over 3 minus 1. This becomes plus, so 2 all over 2 or 1. Okay? And I could have looked at this equation. They won't always give you the equation, but my slope is 1 here, so okay. Our average rate of change for a linear function is always going to be the slope. Okay, so let's look at these. After we've found that interval, which of all 3 graphs above has the same? Find an interval. Oh, okay. Find an interval sorry, I can't read. Find an interval of x over which all 3 graph functions above have the same average rate of change. Okay, so we know this last one is always going to be 1. Okay, and then we know, all right, that's just going to be like a 1 over 1 So it's going to kind of look like this. So I'm going to look at this graph over here. It looks like we're going to go up 1 over 1 for this interval. And then it looks like over here we're going to go up 1 over 1 for this interval, okay? So from 0 to 1 on this graph, from 0 to 1 on this graph, looking at our x values, and from 0 to 1 to on this graph, okay, they're going to have an average rate of change of 1, okay? And I'm actually not going to give you a question like this, but I wanted to kind of expose you to a question like this, just so you could see these are the types of questions that could be asked. Maybe even when you get to Algebra 2 and stuff. So just looking at this, up 1 over 1, up 1 over 1, up 1 over 1, they all have the same slope from 0 to 1. So the interval where they're all the same is 0 to 1. Okay? All right, so please feel free to ask me any questions. I'm going to be on Zoom calls this week, so on Tuesday and Thursday from 2 to 2:45. So if you guys need my help, feel free to click on that link that I send y'all in your email. And I'm here for y'all. I miss you guys. And again, feel free to email me with any questions. I will even make individual videos if you need some extra help with this. But love y'all and I miss y'all. Bye.